We're going to be finding probabilities of normal distributions on our calculator. So here we have a question: find the probability that the random variable z is between negative 0.72 and negative 0.41. Now the hint in this question is that we're asking for z, not x. So if you ever see the letter z, it means that we're dealing with not just any normal distribution, we're dealing with a standard normal distribution. Now what does it mean that it's a standard normal distribution? It means it has a mean of 0 and a standard deviation of 1. Alright, so that's all contained within that little question there. This red stuff, you have to know that if it's z, that's true. Okay, calculator, stat. Go into stat mode. When you go into stat mode, it'll look like this. Distribution, and then choose a distribution. I'm choosing the normal distribution over here, and then I'm choosing NCD, not NPD, and not this one. We'll use that one a bit later. NCD. Okay, now this needs to be set to variable, so VAR. Put in our lower value, negative 0.72. Put in our upper value, negative 0.41. Now we need to make sure these are filled out correctly. This is the standard deviation, it's 1. This is the mean, it's 0. Now go down a little bit further and you'll see the word draw appear here. I'm going to draw this. And it gives us this handy little thing here. It's a drawing of the standard normal distribution, and then a little area coloured in which represents our probability between negative 0.72 and negative 0.41. Now, in this case, the probability is equal to 0.1051, and you can see it down there. 4 decimal places is a pretty good standard to go with here. If this wasn't in an exam, the things that you would write down are here. So, alright, low equals 0.72, upper equals negative 0.41, standard deviation equals 1, and mean equals 0. That's what you should, I'll just write GC up there. As long as you write that into your exam paper and you give us the probability, you're in business. Alright, let's look at a different one. Go on. It's important to note that this less than sign and the less than and equal sign in normal distributions, they're interchangeable. They're the same thing, because the probability of having less than or equal to negative 0.41 is actually equal to having the probability of less than negative 0.41. You can talk to me in class about why that is, but in essence, you can ignore whether it says less than or equal to or less than in normal distributions. In binomial distributions, that's actually a really, really important thing. In standard normal distributions or normal distributions, you can leave it. Here's another question: the probability that z is greater than 0.2. Now again, the hint is that we've got a z there, so that means that it's a standard normal distribution. Alright, let's jump into it. Distribution, normal distribution, NCD. Now if it's greater than 0.2, we can write in our lower as being 0.2. And then our upper, we're just going to write in, it's greater than 0.2, so it's 0.3, 0.4, up to like 100, a million, 10 million, whatever. So we're going to write in just a very big number here, 9999999. That'll do, that's a big number. Mean is 1, mean is 0, standard deviation is 1. Down here, draw it. And you can see, again, it colours us in a little normal distribution. Here you go. And it gives us our probability. Probability equals 0.4207. I should just write it here, 0.4207. That's it. Again, you would need to draw in all of that stuff. You need to write all of that into your exam paper. All right. So here's another style of question you might see. Now this is not a standard normal distribution. The hint is with the x's, and we only use z's for standard normal distributions. This is a normal distribution, it's not a standard normal. And here is where we'll get our information. This says x is a variable in a normal distribution with mean 16, and standard deviation 4. You need to be very comfortable with that notation. X is a variable in a standard normal distribution, mean 16, standard deviation 4, then the probability that x is greater than 11.5 is equal to. Alright, going to our distribution. Oops. Try again. Distribution, normal distribution, NCD. Alright, so what are we doing? We're doing a lower of 11.5, an upper of a very, 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 very large number. 4 is our standard deviation, and 16, and we'll draw that. And we get something that looks like this. The answer is 0.8697. Just with this question, I might just show you one more version of this. The probability that x is less than, let's say, 17. So if you were asked with the same distribution, probably that x is less than 17, go back here. Now this time our upper bound is 17, and our lower bound is a number that's very, very small. So say negative 99999. And again, we'll just draw that. And we get the probability of 0.5987. And again, you'd have to show all of this stuff if you're doing that in an exam. Do one last question. A dog's average lifespan is 12 years, so that's our average, with a standard deviation of 2 years. That's our standard deviation. What is the probability that the dog lives more than 9 years? So the question really boils down to, what's the probability that the age, the random variable x, is greater than 9 years in this particular thing? I guess I could write in all of that stuff if I wanted to. I could write x is the normal distribution 12, 2. Okay, so if the probability x is greater than 9, distribution, normal distribution, NCD, greater than 9, so the lower is 9, the upper is a very, very, very large number, and to 12. Draw it. And there we have it. The probability is very high. It's 0.9332. That's how you calculate standard normal distributions on your calculator, both standards when you see the Z, and just normal distributions where you're given the mean and the standard deviation.